We are working on the Hungry Traveling Snake project, or well, a game with a twist for the YBite Python curriculum available at www.ybyte.in. We have a snake head which can move around, turn nicely as we have all these foods which have been sprinkled all around. Now we are at a point where we must determine if a particular food is being eaten by the snakehead. Now, the way we are going to do this is in fact very, very similar to what we did in Scratch. Basically, remember there was a snakehead, there was a sprite, the food. We would just go near the sprite, and if we are touching that sprite, if the two sprites are touching each other, that is, we say that the fruit is being eaten. But now the problem here is that we don't have a direct block for let's say determining the two sprites are touching, or in this case two turtles are touching. What we are going to do is use the notion of distance, and basically if the distance between two turtles goes, let's say, below a certain threshold, then we determine that these two are touching each other. It turns out that in fact this is a very interesting thing with a lot of thought that needs to be put in to make sure that the game keeps working quite fine. Let's get started, however. So, I'm going to stop this game here. Remember, we had a list called eaten, which is all set to false because none of the foods has been eaten. So what I'm going to do is that I'm just going to say, okay, look, while the game is not over, I'm going to come in here and say, look, let me just, look through the entire list of, let's say, foods that I have. So I say for KK in range, let's say n, n foods, because that's the number of foods that I have. I'm going to say, if a particular food has not been eaten, remember the food being eaten or not is captured in this list. Let's say this list eaten. So I'm going to say if not eaten, for example, KK. Remember the list eaten is in perfect sync with the list of foods. So basically, I'm just going element by element and seeing if this particular food has not been eaten. I find out the distance between the food item and the snakehead. I remember my snakehead is called T, so I just say t.distance. Now we'll spend some time looking at t.distance a little bit more closely later, but I'm just going to say list, say, of foods, say KK. I'm just finding out that if the distance between the snakehead and that particular list of food, if it is below a certain threshold, so right now I just put a threshold of 20. Later on, we'll spend quite some time discussing how this number comes about, what are the trade-offs, and what are the points that we should be careful about. But right now, I just say, okay, look, if the distance is less than 20, then I say, okay, that I say that the food has been eaten. So I just go and set eaten KK to, let's say, true. I also go and change the color of that particular turtle to, let's say, green. So dot color, and I make it, let's say, green. Now again, obviously you can choose any color that you wish to, but that's what I'm going to do. Now there are 2 points that I want to make about this code. Number one, I have done this before I move the head forward. It really shouldn't matter, but I think this is a little bit more logical and kind of becomes more handy little later. Number two, notice that the way this code is written, once the food has been eaten, we are not going to compute the distance between that food item and the snake head, because distance computation presumably is a mathematical operation. We would want to do it only when necessary. Let's first see this working. Let's kind of convince ourselves that this works, get a feel for this, and then we are going to explore a little bit more detail about the distance and how we are setting this number. What are the trade-offs there? So notice when I run this project, I get these foods coming out. Whenever I get close to a particular food, it immediately turns green. And that's because it indicates that this food has been eaten. Now, like I said, this is very similar to Scratch going, into Scratch where we had the touching condition. Basically, it's like saying that if this turtle snakehead is touching the food turtle, then let us declare that the food has been eaten. And now I've finished eating all the foods. Now we see that with the step of 10 steps, this worked quite fine. In fact, we can also try this with, let's say, 20, and we'll talk about the trade-offs a little bit later. But if I do with 20, my snake goes a bit faster, but in fact, it's quite robust. It still manages to eat the fruit that it comes near. So, the recognition still happens, right? So it's kind of quite fine even with speed of 20. In fact, as we'll discuss later, there is an interesting trade-off between the step size that we are taking, between the size of the turtle itself, between the threshold that we've chosen for the distance, and how easy or how pleasant the game goes. We'll talk about that later. But before I wrap this up, remember in Scratch we were using the touching conditions, sprites touching each other. It was quite convenient. Here we have to do a little bit more. We have to compute the distance between the two turtles, see if it's below a certain threshold, and then we declare that they're touching. And given that we have the choice now to decide this threshold, in fact, we have to be a little bit careful, and we'll discuss this in the coming videos. I hope you found this interesting. In general, if you think this way of learning by building activities, by seeing concepts in action, is something that appeals to you, look at our website www.ybyte.in because we have many such activities. Take care. Thank you so much. Bye bye.